Write the equations and determine if they're parallel, perpendicular, or neither. All right, so we did this on our prior quiz for one line, right? You had to find the equation of this and find the slope of a line. So if I look at this first line here, I have a point here, right? I have a point here, all right? So y-intercept is easy, right? It's where it crosses the y-axis. So my b is going to be what for that line? What's my b for that first line? Negative 1. How do I find my slope? I just walk it, right? Rise over run. So I'm going to say up 1, 2, 3, 4, 5. That's my numerator. Over 1, 2, 3. That's my denominator. So 5/3 is my mx plus b. Right? Let's look at the second line. Y-intercept, that's right here. What is my y-intercept? 1, 2, 3, 4, 5, right? 5. All right, to find slope, I'm going to pick another point. Well, there's a point right here. Down 1, over 1. That's negative 1 over positive 1. What is my slope here? So negative 1. So negative 1x plus 5. Everybody see those two lines and how I got them? Are they parallel? How do I know that? They don't have what?
They're not like they're touching.
They're not.
Just visually, you can see they're not parallel. If I didn't have a picture, how would I know? The slopes are what? They're not the same. If they were parallel, my slopes would be the same, correct? Are they perpendicular? Visually, you might not be able to tell, but what should happen with the slopes if they are perpendicular?
Wouldn't the second one be negative 5 over 3?
Negative 3 over 5, negative reciprocal, right? So these are also not perpendicular. They are neither. They're just intersecting lines. Right? Make sense?
So, like, all right. Why didn't you?
All right, so the first guy, we actually don't know the y-intercept of the first guy. It's like we would have to actually calculate it. I'm not going to make you calculate it just for time's sake. We'll look at the second guy. We're just going to figure out slope. So I'm just going to figure out the slope of this one and then the slope of that one, okay, to see if it's parallel. So for slope, I'm going to pick two points that are on perfect. So this is a point and this is a point. I go down 1, so that's negative 1. And I go over 1, 2, 3, 4, 5, 6. So that's positive 6. So my slope here is negative 1/6. Let's look at this slope. I can use this point again. That's fine. And I'll use this point. I go up 1, 2, 3, 4, 5, 6. So that's positive 6. And I go over 1. Over 1. I can confirm that those are indeed perpendicular because 6 and negative 1/6 are negative reciprocals of each other. You flipped it and you changed the sign. This one we are looking specifically for the line parallel. We have x minus 9y equals negative 1. So for your homework, I do expect you to write out the problem and to show me your work, even if you get the answer wrong. Okay? So this is number 19. The first thing I need to do is figure out the slope if I want a line parallel to it. How do I figure out the slope? I need to put it in what form? Slope-intercept. So I'm going to need to move that x over. Negative 9y equals negative x minus 1. And I divide everything by negative 9. So in slope-intercept form, this guy is y equals negative 1 over negative 9 is positive 1/9. And then, of course, negative 1 over negative 9 is positive 1/9. The only thing I care about here is the slope because I want parallel. All right, so I have this. The only thing I really care about with this line is the slope. They want a line that is parallel to this line. I only need the slope. So if I'm talking about a line that's parallel, then the line that I am talking about is going to have the same slope. They gave me the point. The point they want me to go through is negative 1 at negative 8. So point slope is the equation I'm going to use. You should have had your notes on this So your point slope looks like this. This is m, this is x1, this is y1. Just plug it in. Y minus a negative 8, that looks like plus 8, right? 1/9 is my m. X minus a negative 1 is plus 1. To finish this guy out, I need to just distribute because they want it in slope-intercept form. So I need to distribute my 1/9. So y plus 8 equals 1/9 x plus 1/9. And then I need to subtract my 8. I get y equals 1/9 x, and then I need to deal with these guys right here. I have 1/9 minus 8/1. I need what? Common denominator, right? Which is 9. So this becomes, what's 8 times 9? 72/9. 1/9 minus 72/9, that's just 72 minus 1, right? Which is 71, and it's negative because that guy was negative. So it's a hideous y-intercept, but it is a y-intercept at that, okay? At least it didn't ask you to graph it. For this one, we are going to do perpendicular. So we're going to say the line that they gave us was 5x plus 7y equals negative 12. They want it to be perpendicular to that line. Again, I need it in slope-intercept because I need to know what my slope is. So move your 5x over. It becomes a negative 5x because I moved it across the equal. Divide by your 7. So y equals negative 5/7 x minus 12/7. The only thing I care about for this line is the slope. They want me to write an equation that is perpendicular to this guy. If this slope is negative 5/7, what is it going to be for perpendicular? Positive 7/5. So my slope is positive 7/5. They gave me the point that I want to go through. They gave me the point 30. So I'm going to use my point slope again. I'm going to use this guy again. This is my m. This is my x1. This is my y1. So I'm going to say y minus y1 equals m x minus x1. Y minus 0 is just y. So then I just have to distribute this guy. 7/5 x. 7/5 times negative 3. 7/5 times negative 3/1, right? It's going to give me negative 21/5. So I'm going to say minus 21/5. So just let's think about what an inequality is. So remember when you had an inequality on a number line, you had a set of numbers as your answer. The same is true for linear inequalities. So for linear inequalities, we are going to have a set of numbers for our answer. All right? They show us graphing in two ways. The first way we're going to graph is going to be in slope-intercept form, and then we're going to graph with standard form. Just to show you a vertical line with greater than less than. The vertical line here is x equals 3. So x equals 3 is a vertical line at 3 on the x, right? This is my x equals 3. If I were to have less than 3, it makes sense I would be on this side of the graph, right? If I were to have greater than 3, it makes sense I would be on this side of the graph. But when you start having lines that aren't vertical or that aren't horizontal, then figuring out what's greater than or less than is a little bit strange sometimes, depending on the slope that you have. So you really just look at the y. Is the y bigger or is the y greater? So that's why we graph, first of all, in slope-intercept. First in slope-intercept. So let's look at this. They give us 2x plus y is greater than 3. All right? So I'm going to put this in slope-intercept form first, which means I need to move the x over, right? So I'm going to say y. I'm going to keep this a greater than, is greater than negative 2x plus 3. Negative 2x plus 3. And then I'm going to graph it. All right? Now, a couple things to point out. When we were doing inequalities, so let's say we had x is greater than 3 on the number line. We would go to 3, and then what would we do? if we graphed it. Dawson?
Since x is greater, you do like a circle and then you...
Yeah, we're going to do an open circle specifically, right? A circle there. We're not going to fill it in, and we're going to say everything bigger. So what's the difference between that and this?
It's a closed circle.
It's a closed circle. It indicates that the 3 itself is part of the answer, okay? Right? So the same reason that we did that piece of it, we are going to look at that as well when we start doing these lines. This is just greater than. So if it is just greater than, then the line itself is actually not part of my answer. Well, I can't do a circle around a line, so we do a dashed line, okay? So if you have just greater than or just less than, you are going to use a dashed line here. If you have greater than or equal to, less than or equal to, you're going to do a solid line, okay? So the first thing we need to do is figure out where the line is. I'm going to start on my y-intercept. What is my y-intercept? Positive 3, right? My slope is -2, which is -2/1. So how do I move? How do I move from this positive 3? Down 2 and right 1. Okay, so down 2 and right 1. Or I could go up 2, left 1. Either way, I need a negative slope, right? And then I am going to connect the dots. The difference here is that I am going to connect these with a dashed line. So when you're using a pencil, and I mean, I would recommend a straight edge. You can either dash it with your straight edge or you can go back and erase part of it. But you do need to indicate that it is not a solid line. So you can see that instead of doing a solid line, I am doing this dashed line. That is comparable to the open circle when you were graphing just on a number line. Dashed line, okay? Now, y is bigger than this line. So to graph this, I am going to look at my graph and I'm going to say, where is my y-intercept? It's right here. Everybody see that? 3. I'm going to use my y-intercept. So if I were just looking at the y's, where is greater than? Well, greater than's up here, right? Where is less than? Well, less than's down here. So my y is getting bigger up here. Y is bigger than this line. So that means I need to shade a certain amount because I have a set of numbers that is my answer. So my shading for this is going to go here, which means any number all around here should work for this line. All right, it should work for this line. Y is bigger than that line. So I go to my y, I figure out which side of the line y is getting larger on, and I shade that. And every single point in that shading is my answer.
So do we have to carry our arrow all the way?
So let's say you always want to check your work. I have some people that always want to check their work, which is fine. Pretty good attribute to have. You can pick any number that's in that shading and see if it works, all right? So for example, 3, 0, this point right here is in the shading. Everybody see that? So the point 3, 0 should make this to be a true statement, right? So I plug it in. My y, well, that's 0, is greater than -2 times 3 plus 3. Or you could go back to your original, which is probably even better in case you messed something up in the whole transitioning it to slope-intercept. 2 times 3 plus 0 is greater than 3. Is this true? Okay, well, 0 is bigger than -6 plus 3. 0 is bigger than -3. Is that true? Yeah, that's true, right? 0 is bigger than -3. What about this guy? 6 is bigger than 3. So whether I plugged it into my y-intercept form or my original, when I picked a point that was in my shading, it gave me a true statement when I plugged it back in. So you can check to make sure you shaded the right side of the line by just picking a point and seeing if it works. If you pick a point not in the shading, it should give you a false statement, okay? Because your book actually recommends that you choose 0, 0 to check it. All right, so let's look at 0, 0 here. Is 0, 0 in my shading? No, it is not. So if I plug it in, I should get a false statement, correct? So let's see if I do. If I go to my original And I have 0, 0. So 2 times 0 plus 0 is greater than 3. 0 is greater than 3. False. That should not be in my shading, and you can see that it is not, okay? So they recommend that you check a point, and it's easiest to check 0, 0 if that isn't on the line, all right? But you just have to know, should that be in my shading? Should it give me a true statement? Or should it not be in my shading? Does it give me a false statement? And it's a good way to check, did you shade the right side of your line? All right? So had this been or equal to, the only difference is I would have made it solid. All right? Greater than, I'm going to shade above the line, meaning where my y is getting bigger. Less than, I'm going to shade below the line, where my y is getting smaller. That is only if it is in slope-intercept form. Only if it is in slope-intercept form, which I actually always recommend graphing it in slope-intercept, but we are going to do it one more way. All right, so go ahead and try one. I want you to graph. Actually, I just want you to do 20 here. So for this one, where do I start, by the way? -6. So I'm going to start at -6. What is my movement? Up 2 over 1. So I'm going to go up 2 over 1. Is my line solid or dashed? I know that because it is or equal to, right? So I'm going to make this a solid line. All right. And then is y bigger than this line or smaller than this line? Greater than, right? So I'm going to shade where my y is getting bigger. My y is getting bigger up here. Yes? To solve for y, get it in slope-intercept form is what it's telling you to do. And then graph it based on slope-intercept form. This becomes really, really important when you have a negative in front of your y, because then you apply the rules of greater than, less than. What happens is your greater than, less than will actually flip if there's a negative in front of the y. So it's going to throw you off if you don't get it in slope-intercept form. If you try to graph using your x and y intercepts like we did at the beginning, we were just graphing lines in standard form, then your shading may be off because of your coefficient in front of your y. If you don't have an or equal to, your line is going to be dashed. So if it's just these two, dashed line or equal to solid line. And then you can always choose a test point. Pick a point that is in your shading. It should give you a true statement in your formula for your line. So let's look at this example here. 6x minus 2y is greater than or equal to -10. If I just wanted to graph the line, I could say, well, let me just find my intercepts, pop it in, and graph the line, right? But now I have to worry about shading, okay? So I want to get y by itself to see where is my y bigger or smaller? What is it actually asking? It looks like it's going to be a greater than, right? It says greater than right there, okay? But is y bigger than my answer? That's what I need to know. And so if I get this in slope-intercept form, I'm going to move my 6x over. So I have -2y is greater than or equal to -6x minus 10. What's my next step here?
You
Divide everything by -2, right? This becomes y. What happens here when I divide by -2? Right. Do you remember your rules of inequalities? When you divide by a negative, you flip your inequality. So all of a sudden, I thought this was a greater than, that y was going to be greater than, but y is actually less than or equal to. All right? So instead of shading above this line, I'm going to end up shading below it, right? And so that's why getting it in y-intercept is important, because then you can visually see, oh, which way my actual shading should be, okay? So -6 divided by -2 is +3. -10 divided by -2 is +5. So I am going to have a positive slope. Now, up 3 and right 1 is going to take me off my graph, right? So keep in mind, 3 over 1 slope is the same thing as -3 over -1. Two negative movements work out the same. So I can go down 3 and left 2, and I still have that positive slope, okay? Is this going to be a solid or a dashed line? Solid. How do I know that? Or equal to, right? Or equal to. And then let's talk about my shading. All right. Y is smaller or bigger now that I have found it in slope-intercept? Smaller. So I'm going to look at where I cross the y right here. Which direction is going to be smaller? It's going to be down here, right? This is where I'm going to shade for this guy. Look and see where your y is smaller. Your y is smaller on that side of the line. If I want to check this, I'm going to pick a point that is in my shading, all right? In this case, the easiest point, if 0, 0 is in your shading, pick him. He's the easiest one, okay? So 0, 0, that is in my shading, which means he should give me a true statement. So I'm going to go back up here, and I'm going to plug in 0, 0. So 6 times 0 minus 2 times 0 is greater than or equal to negative 10. That's just 0 minus 0. So 0 is bigger than negative 10. Is that true?
Yeah.
Yes. So a point that was in my shading gave me a true statement. So yes, I checked it. I shaded the right side of it. The correct side of it.